Hello everyone, today we'll start with relational algebra. So relational algebra is a formal language which is used to query and manipulate relational databases. It provides a set of mathematical operations which can take one or more relation as an input and then it is going to produce a new table as an output. Some basic relational algebra operations are selection, projection, union, set difference, Cartesian product and rename. Selection is the type of operation where it is going to display only the specific rows which follows a specific condition. So for an example, here we are going to give the condition as the branch should be CSC from the student table. So it's only going to select the students who belongs to the CSC branch. Next, we have projection. So here the projection is going to display specific columns. So selection was displaying specific rows, and then this is projection is displaying specific columns from the relation, and then it's also going to remove duplicates automatically when we give the command. So here we want to select in the example we want to select the name and the marks row column from the student table. So when we are giving this mathematical operation, that is the projection, the result is going to be your name and marks only. Next, we have the union. So the union operation is going to combine all the tuples from the two compatible relations. Compatible relation in the sense that both the tables which we are combining should have the same attributes and the same number of columns. So, and then it's also going to remove the duplicates. Example is simple, table 1 union table 2, and then we are getting the result as our in the table 1 we have roll number 1 and 2, table 2 we have our roll number 2 and 3. So now in the results we are going to have 1, 2 and 3. The duplicate roll number 2 has been removed. So that is the use for union. Next, we have set difference. The set difference operation is going to return the tuples that are in the first relation but that are not in the second relation. So here we have two tables, student and student new. In the student table we have roll number 1 and 2, and in the student new table we have the 2 and 3. So it's going to return the roll number 1 because it's there in the first table but it is not there in the second table. So that is the use for the set difference. Next, we have the Cartesian product. Cartesian product is going to return all the possible combinations of the tuples from the two relations. So it is also known as the cross product. So we are going to multiply. See, so the first roll number is going to multiply to both the ID and the name for the new table, and then the name is also going to be multiplying to the ID and the name for the next table. So now we have for roll number 1 we have both ID1, department 1 and department 2, and then for roll number 2 again we have 1 and 2 department. So that is how we are doing the Cartesian product. Next we have the rename. The rename operation is used to rename the name of the table. So here we are going to change the name from student to our name to a STU. So that is the function of the rename operation. Next, we have our relational database design using ER to relational mapping. So when we say ER to relational mapping, it is the process of converting our ER diagram to a relational schema. Relational schema, ER diagram is just a diagram, the logical view of how we are going to create a database, and then a relational schema is the actual blueprint of the schema from where we are defining the tables and how we are starting to convert it into the real database, which includes the tables, keys, and the relationship. So why is it important is that ER models it designs the database conceptually, while the relational model is used to implement it on the system such as our MySQL or Oracle. So why is ER to relational mapping important? Because of the data integrity, efficiency, and clarity that it provides in the relational schema. Now we have the steps. How are we going to map the ER diagram to a relational schema? First, we are going to map the regular entities. Regular entities, by regular entity, we mean the strong entity which has its own unique identifier and which can exist alone. So the steps are, we are just converting it. So the entity is going to become the table name. So we have an entity called student. So this student is going to become the student table name. And then all its attribute is going to become the attributes of the table. And then the primary key should be defined. Next, we have the mapping of weak entities. Weak entity does not have its own unique identifier, so it's going to depend on the strong entity, and it does not have the primary key of its own. So in the table, we are going to create two tables, for one for the strong entity and one for the weak entity. And strong entity, we have already discussed how we are going to define the draw the relational schema. And then for the weak entity, when we are drawing the schema, or when we are writing the schema, we are going to add the primary key of the strong entity and then the partial key from the weak entity combined together, and it's going to be the unique identifier for the weak entity. Next, we have mapping of one-to-one relationship. One-to-one relationship means one entity is related to one entity or another entity only. So in this, we are going to add when we are going to convert both the two ER model to the relational schema. That means we are going to have two tables. Let's take an example, manager and branch. So from in this type of one-to-one relationship, we can add the primary key from one table. So manager table primary key is employee number, and then the branch table primary key is branch number. So this branch number, which is the primary key of the branch table, we can either add it to the manager table as a foreign key, or the employee number from the manager table we can add it at the branch table as a foreign key. This is how we are going to map one-to-one relationship. Next, we have mapping from one-to-many relationship. In this one-to-many relationship, we are going to take the primary key of the entity which has only one relationship and put it in the entity which has multiple relationship as a foreign key. Next, we have mapping of many to many. In this same thing, we are going to create the table for all the two entities, and then for the relation itself, we are going to create a new table. So, and in this new table for the relation, we are going to add all the primary keys from the other two entities, and it is going to act as the primary key for the relation. Next, we are going to map multiple values. Multiple value attribute means those type of attributes which can have multiple values. For example, we have our phone number. One person can have many phone numbers. So here, how we are going to map this into the relational schema is we are going to draw the relational schema of the entity itself, that is the person. We are going to convert it into an relational schema table. And then for the attribute itself, we are going to make it as a table. So the name of the table is going to be the attribute name, multi-value attribute name, and then in this the primary key is going to be your primary key of the entity, and then the whatever attribute the multi-value attributes can have, we're also going to add it, and then there's going to be the mapping for the multi-valued attributes. Next, we have mapping of n-ary relationship. When we say n-ary relationship, we mean that when there are more than two entities in a specific relationship. So here how we are going to do it is that we are going to create tables for each and every entity, which includes their own primary key, and then we are going to create the table for the relationship, and then in this relationship table it's going to have all the primary keys of all the entities with the attribute. If the relationship has an attribute, we are going to add that as the attribute of the relationship itself. So for example, we have supplier, project, and part. These are the entities and they are in the relationship called supply. So we are going to have the table for supplier, project, and part, and for the relationship called supply, we are also going to have a table. So in this table, we are going to add all the primary keys of the entities, that is your S name, project name, and part number. And then the supply also have one attribute, that is the quantity. This quantity also we are going to add it as a attribute for the supply table. So that is the mapping of n-ary relationship. Thank you.